Hello guys, this is Prime Concept. Now, in this video, we want to look at motion of charged particle in an electric field. Now, we already know that when you have a charge Q, that this charge creates an electric field around itself, right? Such that if you bring another charge or another charged particle within the field of this, that charged particle would experience an attractive force, right? Now, what we want to consider in this case is if we know the mass of that charged particle that is brought within the field of created by this charge, if we know its mass, we have some information about it, maybe the mass and other things. We want to find the acceleration, we want to find the velocity of that particle, the speed with which it would move, we want to find the distance it will travel. We're going to get it simply by knowing, relating what we have learned in electrostatics. We're going to relate it with kinetics or kinematics, that is motion, uniform motion. Now, we earlier learned, if you recall, that the force experienced by a charge or a charged particle placed in an electric field, that force is given as F equals QE. I believe you remember this, where Q is the charge, the test charge, and then E is the electric field strength, right? So, and from kinematics, you would also recall, or from dynamics, sorry, you would also recall that F force also experienced, if you have that particle, if it is moving, then it will have an acceleration. So the force experience is going to be, would be given as ma. So if you equate these two quantities, you would have that ma, because F is this, F is this, so you would have that ma is equal to what now? QE in this case. And if I make A the subject formula here, I would have that A is equal to QE divided by m. So what I have just been able to derive is the acceleration of a particle that is placed in an electric field. So because we are considering motion, if something is moving, in some cases it should have an acceleration, right? So the acceleration of a particle placed inside an electric field is going to be given as QE by m, where m is the mass of that particle and a is the acceleration, and other things are there. Now say, let me call this our first derived equation. Now say we want to also know the speed. Since we know the acceleration, we want to know the speed or the velocity. Now we're going to assume that, of course, when the particle was placed in that field, it was initially at rest. We're going to consider that to simplify the problem. It was initially at rest before it began to experience an attraction which gave rise to the motion, right? So since it was initially at rest, it simply means that the initial velocity of that particle u is going to be what? 0. And if that is the case, from one of the equations of motion, we have that v equals u plus at, right? So since u is 0, you would have that v becomes just at. Then v, we have a as this, right? So I'm going to substitute. Then v becomes what now? QE divided by m times t. So this is equation 2. So when you are required to get the velocity of a charged particle placed in an electric field, to be given as v equals QE over m multiplied by the time. And the third relationship I want to derive is for the distance traveled by that particle. The distance traveled. Now you also recall one of the equations of motion, that distance s is given as ut plus half at squared, right? Now if, since we have assumed that u is 0, the particle starts from rest, u is 0, then it means that s is going to be what now? Half at squared. So if I substitute, because I know a as this, if I substitute, I would have that s is equal to what now? Half QE by m, right? Times t squared. So this is what I have as the distance traveled by that particle. So this is my equation 3. So I have 3 equations now. Then the last one I want to give you as a bonus is the kinetic energy. So I don't know how many of you can derive this, but let me just do it as a bonus, the kinetic energy. Now, since it is moving, any particle that is moving should have a kinetic energy. We have first established that the particle has an acceleration given by this, it travels with a velocity given by this, and then travels a distance given by this. So the next thing is, what will be the kinetic energy with which this particle is moving? Very simple. I can simply get it from here. Now, if I come to equation 2, I'm going to square both sides of equation 2, right? Now, if I square both sides of equation 2, I would have that v square, which is this, is going to give us what now? Q square E square divided by what? M square times what now? C square. So this is what I would have as the velocity square. Now, if I go back to the formula for kinetic energy Ke is half mv squared, right? Now, if I do that, if I substitute, I would have that Ke is equal to half times m times my v square now is what? Q square E square C square all divided by m square. So that when one m fizzles another m, I would have that Ke is half what now? Q square E square, right? By m. So this is what I would have as my kinetic energy. So we can call this equation 4 the bonus equation, right? Yes. Now you can still do something else, so which I would give you. I would allow you to do that and put the answer in the comment section if you understand. How can you prove from this the work energy theorem? Using this relationship, prove the work energy theorem. Work energy theorem simply says that change in kinetic energy is equal to force times distance. So how do you prove that with this you can arrive at work energy theorem? I believe this whole concept is clear. So do well to note out these formulas. In my next video, I'll take one problem solving this. So do well to note out these formulas and how they were derived. I believe the concept is very clear. Try to subscribe to my channel, like my videos, and share with your friends so that they can also benefit from this. Remember, this is Prime Concepts. Thank you.